Hi, my name is Dana Golden. Today we're continuing along with our Intro to Python lesson, and we're going to start with for loops. So for I in range 10, print I. So this prints from 0 to 9. So notice when you do a for loop using a range, the range is range starts at 0, or it starts at 0, and it ends one number below the last number. So for I in range 1, comma 50, this is going to print everything up to 49 starting at 1. So 1 and then up to 49. So now we can do while loops. I equals 0, while I less than 10, print I equals I plus 1. So with a for loop, this does an action over and over again. It just repeats a singular action. With a while loop, this will iterate until a condition is met. So I equals 0, while I is less than 10, print I equals I plus 1. So it iterates until I is now equal to 10. Define hello world for j in range I, print hello world. So now we have this I, which is a argument to hello world, and then we can do hello world of 10, and then if we add an exclamation point to make it really nice, hello world 10 times. And then we can add an if statement. So now define hello world for j in range I if I less than or equal to 5, print hello world. So we're going to do hello world of 1, and it's going to print nothing. We're going to do hello world 10. It's going to print hello world 10 times. Hello world 100. Hello world of 4 doesn't print anything. So now we're doing square. So square input squared. So these are functions. These take in an input and these do something. Sometimes they return an output. Sometimes they just do something in general, like add a print. So square of 4, 16. Square of 5 is 25. So this is it a square? Checks as to whether or not a number is a perfect square. So math.squared input minus math.squared input equals 0. So into math.squared input, that will be basically a for function. So that will take it down slightly, and this is math.square root of input. So if the square root taken as an int is equal to itself, return true. Otherwise, return false. So this for 4 returns true. For 5, it returns false. But if we square 5 using our square function, that returns true. So list of names equals an empty list. This is dash structured list, so I'm showing you how lists work. So if we do list of names equals empty list, and do print list of names, that's going to end up being just a blank list. And if we append Harry, that's just going to be Harry. And then now, if we add a second list of names, Sally, Pokemon, Batman, Billy, Ibby, Sally, now we have 2 lists of names. If we add together the list of names, we get a third list of names, which is the combination of both lists. We can do the same thing using extend, but now if we do extend, now list of names adds on list of names 2 to itself. So you get that there. Now we start off with list names not remove Pokemon. Pokemon is not defined because it's a variable. We need it. We need Pokemon to be a string there. So let's start off with list names are remove Pokemon. That's not in the list because Python is case sensitive. So list names not remove Pokemon. List names, we removed the name Pokemon. Data structure is tuples. So tuples are like lists, but they are they're defined with parentheses, and there are some important differences that we're not going to get into today. So, print the tuple and len of tuple. So, dictionaries are a much more interesting data structure. Basically, what a dictionary does is it has it has a key and a value, and the keys are related to the values. This is the dictionary, and this is the dictionary of that value. So this allows you to store information that has some relationship. So we do this dict dot keys, and then we do this dict dot values. So the keys, notice, are what you use to retrieve a value, and the values are the values of the dict. So now we have another dict where we add year 2020. Notice that if you have year 1964 and then year 2020, the latest iteration of year is going to replace the earlier iteration of year. So you can also create a dict this way using dicts of the function. So we have a dict of John, age, in Norway. So this is a default dictionary. What default dictionaries do is they return a default value when you use them with a key that's not present. So with the normal dictionary, so like with this dict, if I tried to use this dict with Sally, it's going to return a key error. But here, with the default dict, that's not going to happen because when I query with an unknown key, it just returns a default value. In this case, not present. So equals default dict of default value. D of A equals 1, D of B equals 2. And so here we go. D of A, 1, D of B, 2, D of C, not present. And then D equals default dict of int. So this means just 0. So now for L equals 1, 2, 3, 4. And then for I and L, D of I equals 1, print D. So basically what this is doing is for each value in L, it's counting how many times it shows up. And then if we do D of 7, it says 0 because there's no key error because we have created a default dict. And that returns 0 the first time it sees a key. So factorial, define factorial, if n equals 0, return 1, else return n times factorial of n minus 1. So this is recursion. So basically you're using a function to return, you're using a function as as an input to itself. So define factorial of n. If n equals 0, return 1, else return n times factorial of n minus 1. So this is going to keep going until n is equal to 0, and then it's going to return 1. I think there's actually a flaw here. So let's do factorial 10, and then let's do factorial 5. And then let's see what happens when we do factorial of minus 5. So it's going to keep running forever, and that's going to give maximum recursion depth exceeded. So what's going on here is that you can only do so many recursions, or else it's going to screw up the computer. Not screw up the computer, but like make the function stop running. So how do we fix this? How do we make it so that this will run also with negative numbers? We do factorial of n if n is less than or equal to 1, return 1, else return, or less than or equal to 0, return 1. And then let's do factorial of 10. Less than or equal to, less than or equal to. Factorial of -5. Yep, and that works. So now this is Fibonacci. So this is another form of recursion. Recall that Fibonacci number you add to the previous number, so it's a sequence. If n equals 1, return 1. Else if, using else if, n equals 0, return 1. Else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. So notice if it's 1, we return 1. If it's 0, index, we return 1. Else we return Fibonacci of n minus 1 plus Fibonacci of n minus 2. So let's see what happens when we do Fibonacci of 5. Let's do Fibonacci of 10. And then let's do Fibonacci of 20, of 100. It's going to look at this as doing a bunch of recursions, and then it's going to eventually return the Fibonacci value of 100. Let's instead do that. Let's do for I in range 10. Oh, let's do 20. Print and that just prints all the Fibonacci numbers up to here. Notice that printing Fibonacci's takes a while because it's a recursive process. So let's see if we can do a factorial a little bit faster. So this is a process called dynamic programming. And the idea of dynamic programming is that basically instead of having it call itself, instead of having it do the same thing over and over again, because in factorial you're wasting a lot of effort. Instead of that, what we're going to do is we're going to create a dictionary, and that dictionary is going to save a result, and then we're just going to iterate through the result. So it's going to build up instead of going down, and in that we don't have to call a function a bunch of times. It's not going to waste a bunch of effort. Factorial programming of 5. So the same thing with factorial, but now it's a lot faster. So this is a space memory trade-off. You're trading off space for, you're trading memory for, not a space memory trade-off. This is the runtime memory trade-off. You're giving up memory, but you're gaining runtime. So it's running fast, but you're having to use more memory. So here's how you do Fibonacci with dynamic programming. So now instead of having to call the function a bunch of times, and when you call the function a bunch of times, you repeat the effort. So now you're using a dictionary to just save the value, and you're building up. So Fibonacci dynamic programming 8, it's the same thing. It's just now going a lot faster. This is file layout. So again, if we were doing this on our own systems, we would use os.change get working directory, and then we'd use os.change working directory. Now we used drive.mount, and here we're going to print the row in this order dispatch CSV file. So it prints every single row in my CSV file. And then now we're going to write to a CSV file with names.csv. Write, you have new line, which means how we decide what the new line is, a CSV file. And then we do field names equals write first name, comma last name. And then we do writer equals CSV, comma field names equals field names. And then we write the header, and then we write the rows by using a series of disks. So let's see what happened. We should see oh, there we go. There it is. Names, and notice first name, last name, and then each of the names. So this is a pretty nice function. It allows you to, anytime you want to, write a CSV. We'll talk about later how to do this in Pandas. So now let's try some error handling. So let's say you have a function that sometimes creates errors, but you don't want the function to stop. So how do you do this? So let's start off without this error handling mechanism. So divide x by y. Well, let's see. By the way, let's see what we do if we do this. Let's divide x by y. Divide 5 by 2. Oh. There we go. Yeah, unexpected input. That's what I was wanting. So yeah, you have to use a consistent indent, and if you do, if you use like an if statement, it won't work unless you use this indent. So now let's just return x divided by y, and then return 2 divided by 5. That's fine. But now return 5 divided by 0, and that gives a division by 0 error. So how are we going to fix this? We're going to try and accept. So it's going to try to print x divided by y, return x divided by y. Otherwise, it's going to print can't be done. So for I in range 10, so it's going from 0 to 9, and for j in range 0 to 20 by 2. So 0, 2, 4, 6, 8, and then up to 18. So notice can't be done, 0, 0, 0, and then some fractions, and then more can't be done's. And then now let's talk about classes for a moment. Classes allow you to construct more complex objects. So you have class car, have an attribute car to underscore count equals 0. And then you have an initiation statement, which is you have the self here, you have brand, model, and year. Self.brand equals brand, self.model equals model, self.year equals year, and car.count plus equals 1. And then you have an instant method where it prints. So you have in classes, they can have different characteristics and they can have different methods. So you create this class car, and then you create instances of the class, which are car, which are Toyota Corolla, and then 2020, Honda Civic 2018, Ford Mustang 2022. And then you display info for car 1, which allows you to do this function for car 1. For car drive, you do self.brand, self.model is driving, and then you can access characteristics of the class. So it did the function, and then you can access characteristics of the class by doing dots. This allows you to build up more complex objects in Python. And notice that this is car.carCount. So every time you access car to create a new instance, you added this instance to the class car, which iterated up the car underscore count. So now we have a class of electric car, which we're going to see inherits the constructor of the parent class car. So electric car is a type of car that's going to inherit the characteristics of car. So we're going to do super of init battery brand model year. And then we're also going to have additional attributes specific to electric car, self.battery capacity equals battery capacity, where battery capacity is entered when you create the instance of electric car. And then we have the override drive method. We can create a new drive method for electric car. Print self.brand, self.model is driving silently with self_battery capacity kilowatt hour battery. Select your car, create a model of electric car, Tesla Model S 2023 100. Electric car display info, and then electric car.drive. And there you have it. That is our intro to Python. I hope you enjoyed it. I hope you learned something. Please go through this notebook on your own if you've not already done that. And yeah, I hope you have a great day. I'll see you next time.